From everything we've learned so far, it looks as though the universe began in a state of incredible heat and density, a beginning that scientists sometimes call a singularity. Before the clocks of the universe began to tick, all matter and energy waited in this infinitesimal speck, a space far smaller than a grain of sand. It is difficult for the human mind to grasp such compression, where the vast distances between stars and the swirling arms of galaxies were folded together in a state of pure potential. The laws of physics, as we understand them today, did not yet apply in this dense, hot embrace, leaving the nature of that initial moment a beautiful mystery. From this tiny seed, the grand tapestry of space and time would eventually unfurl, stretching out to hold every world and every dream that has ever existed. It reminds us that even the most magnificent things often have the quietest and smallest of beginnings, waiting patiently for their moment to bloom into existence. Time itself did not exist before this great expansion began. We often wonder what came before the universe, imagining a long period of waiting in the dark. But in the realm of deep physics, the concept of before loses its meaning without space and time to define it. Just as there is no direction north of the North Pole, there was no time prior to this initial moment, for time was woven into the very fabric of the emerging cosmos. The universe did not emerge into an existing empty room. It brought the room and the clock with it, creating the stage for reality as it expanded. This suggests that the universe is not merely a collection of objects floating in a void, but a unified entity where space, time, and matter are inseparable partners. It allows us to view the present moment not just as a fleeting second, but as a continuation of that very first heartbeat of time. The universe underwent a brief but intense period of rapid growth called cosmic inflation. In a fraction of a second, far shorter than the blink of an eye, the fabric of space expanded faster than the speed of light, stretching from the size of a subatomic particle to something macroscopic. This was not matter moving through space, but space itself stretching out, carrying the energy of the cosmos along with it, like leaves on a widening river. This rapid smoothing of the universe ensured that the night sky looks largely the same in every direction, creating a balanced and orderly home for the galaxies that would come later. It was a moment of supreme elegance, where the chaotic energy of the beginning was ironed out into a vast, smooth canvas. This silent, instantaneous stretching set the scale for everything we see, laying the calm foundation upon which the intricate structures of the future would eventually be built. In its earliest moments, the universe was incredibly hot, reaching temperatures that defy human imagination. At the very instant of its birth, the heat was so intense that it is measured in the range of decillions of degrees, a 1 followed by 32 zeros, far hotter than the core of any star that shines today. At these temperatures, matter could not exist in solid or liquid forms, and even atoms could not hold together, leaving only pure, vibrating energy and fundamental particles dancing in the heat. As the cosmos expanded, this immense heat began to spread out and cool, a slow and gentle process that would eventually allow the universe to settle into a more comfortable state. This transition from a fiery beginning to the cool darkness of space we know today is a testament to the soothing power of expansion. It teaches us that given enough space and time, even the most intense energy can soften into a gentle, enduring warmth. The early universe was filled with a unique substance known as quark-gluon plasma. Before protons and neutrons could form to build the hearts of atoms, the cosmos was a dense, liquid-like soup of these elementary particles moving freely in a perfect fluid. This state of matter, often recreated briefly in massive particle colliders, behaved like a frictionless liquid, flowing with a perfect, coordinated grace. It was a time when the distinctions between different types of matter were blurred, and everything existed in a collective, harmonious state of high energy. As the universe continued to cool, these free-roaming particles began to find one another, binding together to form the stable building blocks of the material world. This ancient plasma represents the shared ancestry of all matter, a time when the ingredients of stars, planets, and living things were all mingled together in a single, flowing ocean of potential. A slight imbalance between matter and antimatter is the reason anything exists today. In the energetic forge of the early universe, particles of matter and their opposites, antimatter, were created in nearly equal amounts, dancing in a cycle of creation and annihilation. However, for every billion pairs of antimatter, there were 1,000,000,001 particles of regular matter, a tiny imperfection that made all the difference. When the great annihilation cooled down, that solitary survivor from each set remained, eventually coalescing to form the galaxies, stars, and ultimately us. This subtle asymmetry suggests that the universe favors existence over emptiness, allowing a small remnant to persist and grow into the vast complexity we see. It is a comforting thought that existence hangs on a delicate, fortunate margin, and that out of a chaotic struggle for balance, the enduring beauty of the physical world was allowed to remain and flourish. Gravity began to separate from the other fundamental forces very early in the cosmic timeline. In the extreme heat of the beginning, the forces that now govern our world, like electromagnetism and the nuclear forces, were unified into a single master force. As the temperature dropped, gravity was the first to detach and assert its own identity, stepping back to begin its long, patient work of sculpting the universe. This separation was like the opening note of a symphony, allowing the distinct laws of physics to emerge and play their individual parts in the orchestration of reality. Gravity would go on to become the architect of the cosmos, gently pulling dust and gas together to form the celestial bodies that light up the night. This ancient divergence reminds us that complexity arises from unity, as a single underlying principle unfolds into the rich and varied laws that guide the stars and planets in their silent orbits. The first atomic nuclei formed during a brief window known as the era of nucleosynthesis. Within the first few minutes after the expansion began, the universe had cooled just enough for protons and neutrons to stick together, creating the cores of hydrogen and helium, along with a trace of lithium. This process was remarkably efficient, establishing the chemical composition of the universe for billions of years to come, with roughly 3/4 being hydrogen and 1/4 helium. It was a frantic yet precise manufacturing period where the universe acted as a global nuclear reactor, forging the simplest elements that would later fuel the stars. Once the temperature dropped further, this fusion stopped, and the universe was left with a vast supply of pristine gas waiting for gravity to take hold. This primordial ratio of elements is still visible in the oldest gas clouds today, a chemical fingerprint left over from those first few crucial minutes of creation. For about 380,000 years after the beginning, the universe was a foggy, opaque place where light could not travel freely. In this dense, hot plasma, particles of light, known as photons, were constantly bumping into free-floating electrons, bouncing around like balls in a crowded room without ever getting far. This meant that if you could have been there, you would have seen nothing but a glowing, impenetrable fog in every direction, trapping the brilliance of the early cosmos within itself. This era, often called the photon epoch, was a time of containment, where the energy of the universe was kept close, unable to stream out into the void. It was a long period of gestation, holding the light in a warm embrace until the conditions were right for it to be released. It serves as a poetic reminder that clarity often follows a period of density and confusion, and that light waits patiently for the fog to clear. The universe became transparent roughly 380,000 years after the Big Bang in an event called recombination. As the expansion continued, the temperature finally dropped enough for electrons to slow down and be captured by atomic nuclei, forming the first neutral atoms. With the electrons now bound in orbits, the fog cleared, and the photons of light were suddenly free to travel unimpeded across the vastness of space. This moment was the cosmic equivalent of the clouds breaking after a long storm, releasing a flash of light that would journey for billions of years. This ancient light is still traveling today, stretched by the expansion of space into invisible waves that fill the sky. It marks the transition from the primordial era to the age of atoms, a serene unlocking of the universe that allowed the visual history of the cosmos to finally begin being written. The afterglow of the Big Bang is still visible today as the cosmic microwave background. When the universe cleared and light was released, it was incredibly bright and hot. But over billions of years, the expansion of space has stretched that light into cooler, longer microwave wavelengths. This faint glow comes from every direction in the sky with almost perfect uniformity, acting as a backdrop to all the stars and galaxies we see. It is the oldest light in existence, a fossilized relic that provides a snapshot of the universe when it was just a newborn, long before the first star ignited. Astronomers map this subtle radiation to understand the seeds of the structures we see today, reading the temperature fluctuations like lines on an ancient map. This gentle, omnipresent hum of energy is a constant reminder that the fires of the beginning have cooled into a peaceful, rhythmic whisper that fills the entire cosmos. Before the first stars ignited, the universe entered a period known as the Cosmic Dark Ages. After the initial flash of light from the Big Bang faded and shifted into the infrared, the cosmos was filled with dark clouds of neutral hydrogen gas and no sources of visible light. It was a time of profound silence and darkness, lasting for hundreds of millions of years, where the universe was essentially a vast, sleeping ocean of gas. During this time, gravity was quietly working in the shadows, slowly pulling denser regions of gas together, preparing the stage for the first lights to turn on. This era was not empty, but rather pregnant with potential, a necessary slumber where the materials for future galaxies were gathering their strength. It illustrates the beauty of the quiet times in history, where nothing seems to be happening on the surface, but the foundations of a brilliant future are being laid in the deep. The very first generation of stars, known as population 3 stars, were likely massive and luminous giants. Unlike the stars we see tonight, which contain traces of heavier elements, these ancient ancestors were made almost entirely of pristine hydrogen and helium from the Big Bang. Because the gas was so pure, these stars had to be enormous to ignite, often hundreds of times more massive than our own sun, burning with a furious blue intensity. They lived fast and died young, burning through their fuel in just a few million years before exploding in spectacular supernovae. These explosions were crucial as they forged the first heavy elements like carbon and oxygen, scattering them into space to seed future generations of stars. In their brief, brilliant lives, they transformed the sterile universe into a chemical garden, sacrificing themselves to create the ingredients necessary for planets and life. The first galaxies likely grew from tiny fluctuations in the density of the early universe. In the immediate aftermath of the Big Bang, matter was not perfectly evenly distributed. There were microscopic clumps where the density was slightly higher than average. Gravity latched onto these subtle imperfections, pulling more and more dark matter and gas into them over millions of years, acting as the seeds for structure. These growing clumps eventually ignited with the light of the first stars, forming the protogalaxies that would merge and flow together to create the majestic spirals and ellipticals we see today. It is a testament to the power of small things, showing how microscopic differences in the beginning can cascade into the grandest structures of the cosmos. This process continues to remind us that large, beautiful systems often arise from the most delicate and seemingly insignificant variations in the pattern. The expansion of the universe is still happening right now, carrying galaxies farther apart every second. This discovery, made by observing that distant galaxies are moving away from us in all directions, changed our view of the cosmos from static to dynamic. It is not that the galaxies are flying through space like rockets, but that the space between them is physically growing, like dough rising in an oven. This means that on the larger scales, the universe is getting cooler and emptier as time marches on, continuing the motion started by the initial Big Bang. The rate of this expansion, known as the Hubble constant, is a key number that helps us measure the age and size of everything around us. It paints a picture of a universe that is still breathing, still unfolding, and still in the process of becoming, rather than a finished painting hanging on a wall. A mysterious force known as dark energy is causing the universe's expansion to accelerate. For a long time, it was thought that gravity would eventually slow down the expansion of the cosmos, perhaps even pulling everything back together. However, observations of distant supernovae revealed that the universe is expanding faster today than it was in the past, driven by this invisible energy that permeates all of space. Dark energy acts as a sort of reverse gravity, pushing space apart gently but persistently, and it makes up the majority of the energy budget of the universe. Its nature remains one of the greatest mysteries in science, a silent engine that dictates the fate of the cosmos on the larger scales. This acceleration suggests a future where the universe becomes vast and lonely, a slow and majestic drift into an ever-widening silence, emphasizing the profound dominance of the void over matter. Dark matter acted as the invisible scaffolding for the visible universe, while the ordinary matter that makes up stars and gas was too hot and energetic to clump together initially. Dark matter was already pooling into dense halos, unaffected by the pressure of light. These invisible pockets of gravity provided the anchors that attracted the normal hydrogen gas, allowing it to settle and form the first galaxies. Without the stabilizing grip of dark matter, the beautiful structures we see in the telescope might never have formed or would have flown apart long ago. It is a substance we cannot see or touch, known only by its gravitational influence, yet it holds the visible world in its embrace. It serves as a reminder that the most essential support systems are often unseen, silently holding up the bright and beautiful parts of reality from the shadows. The Big Bang was not an explosion in space, but an expansion of space. The term Big Bang often conjures images of a bomb going off in an empty void, sending shrapnel flying outward, but the reality is far more subtle and all-encompassing. The event happened everywhere at once, because everywhere was contained within that initial point. There was no outside for the universe to explode into. As space stretched, it carried matter with it, meaning that every point in the universe can essentially claim to be the center of the expansion. This concept shifts our perspective from witnessing an event at a distance to realizing we are inside the event itself, as the expansion is still the environment in which we live. It unifies all observers in the cosmos, suggesting that every galaxy and every star shares the same origin story, expanding together in a grand, shared journey through time. The lithium in our universe presents a lingering puzzle known as the cosmological lithium problem. Our theories of the Big Bang predict exactly how much hydrogen, helium, and lithium should have been produced in the first few minutes of nucleosynthesis. While the predictions for hydrogen and helium match observations perfectly, the amount of lithium we see in the oldest stars is only about 1/3 of what the theory suggests. This discrepancy suggests that there may be something subtle we do not yet understand about the early universe or the behavior of particles. It is not a failure of the model, but a whisper of hidden complexity, a clue that there are still secrets waiting to be uncovered. Such mysteries keep the story of the universe alive and evolving, reminding us that even in our best understanding, nature always holds back a little mystery for us to ponder in the quiet hours. The observable universe is now roughly 93 billion light-years in diameter. Although the universe is only about 13.8 billion years old, the space itself has expanded so much that the light has traveled across a much larger distance to reach us. This sphere, centered on Earth, defines the absolute limit of what we can see, encompassing roughly 2 trillion galaxies, each an island of starlight. Beyond this horizon, there is likely much more universe, perhaps infinite in extent, but the light from those distant regions has not had enough time since the beginning of time to reach our eyes. This immense scale transforms our feelings of smallness into a sense of awe, placing us in a vast, cavernous hall of existence that extends far beyond our perception. It invites us to rest in the knowledge that we are part of something limitless, a grand and silent expanse that continues to grow with every passing moment. Sound waves traveled through the infant universe long before there were any ears to hear them. In the dense, hot plasma that filled the cosmos shortly after the beginning, pressure waves moved like ripples in a pond, driven by the intense battle between gravity pulling matter in and radiation pushing it out. These ancient sound waves, known as baryon acoustic oscillations, compress the gas into slightly denser shells, creating a vast, three-dimensional pattern of ripples across the darkness. Although the sound was far too deep for any human to perceive, roughly 57 octaves below middle C, it was the rhythmic heartbeat of the early creation. As the universe expanded and cooled, these waves were frozen in place, leaving their imprint on the distribution of galaxies we see today. It paints a picture of the early universe not as a chaotic explosion, but as a resonant, vibrating instrument, humming a low and steady note that set the structure of the heavens. The geometry of the universe appears to be remarkably flat on the largest scales. This does not mean the cosmos is two-dimensional like a sheet of paper, but rather that parallel lines traveling through space will remain parallel forever, never meeting and never diverging. If the universe were curved like a sphere, those lines would eventually cross, but measurements of the ancient background light show a precision that suggests an expansive, level playing field for reality. This flatness indicates that the total energy of the universe is perfectly balanced with its gravity, a cosmic equilibrium that allows the expansion to continue smoothly. It creates a sense of infinite, open potential, where light can travel in straight, unwavering paths across the billions of years. This vast, flat stage provides a calm and stable foundation for the intricate dance of galaxies, stretching out endlessly into the deep horizon. A ghostly ocean of neutrinos was released just 1 second after the Big Bang. These tiny, nearly massless particles were forged in the intense heat of the first moments and immediately flew out into the void, passing through matter as if it were not there at all. Today, this cosmic neutrino background fills every corner of space, with millions of them passing harmlessly through your body every second, ancient messengers from the beginning of time. Unlike light, which was trapped by the cosmic fog for thousands of years, neutrinos broke free almost immediately, carrying the earliest possible snapshot of the universe. They form a silent, invisible web that connects us to the very first second of existence, flowing around and through us like a gentle, imperceptible breeze. It reminds us that we are constantly bathed in the legacy of the past, touched by particles that have traveled since the dawn of creation. The first chemical bond in history was formed between helium and hydrogen. In the cooling dawn of the universe, roughly 100,000 years after the beginning, these two simple elements combined to create a fragile molecule called helium hydride. It was the universe's first step toward complexity, the very first time atoms decided to hold hands and create something new, rather than drifting alone in the dark. Although this molecule is rare and unstable today, its formation marked the opening chapter of chemistry, proving that the laws of nature favored connection and combination. Scientists searched for this elusive molecule in space for decades, finally finding it in a distant nebula, a lingering echo of that primordial union. It stands as a poetic testament to the urge for unity, showing that even in the vast emptiness of the early cosmos, the drive to bond and build was already active. Light from the early universe arrives at Earth stretched and reddened by its long journey. As photons travel across the expanding fabric of space, the waves are physically pulled apart, shifting their color toward the red end of the spectrum, a phenomenon known as cosmological redshift. This means that the light we see from the most distant galaxies has been softened and mellowed by the vast distances it has crossed, transforming from energetic blue or ultraviolet light into a gentle infrared glow. It is as if the universe itself acts as a filter, taking the harsh brilliance of the ancient past and delivering it to us as a warm, quiet signal. This reddening allows astronomers to measure the distance of celestial objects, reading the color shift like a cosmic odometer. It teaches us that the journey changes the traveler, and that the light of the past arrives to us transformed by the sheer majesty of the space it has traversed. The very first fraction of a second is shrouded in a mystery known as the Planck epoch. Before the universe was even 1/10,000,000th of a trillionth of a trillionth of a trillionth of a second old, the laws of physics as we know them break down completely. In this unimaginably brief moment, gravity was as strong as the other fundamental forces, and the curvature of space-time was so extreme that the concepts of size and duration lose their meaning. It represents the absolute limit of our knowledge, a veil behind which science cannot yet peer, where the universe existed in a state of perfect, unified singularity. This era is the silent, impenetrable seed from which all time and space blossomed, a secret kept by the cosmos itself. It invites us to respect the unknown, acknowledging that at the heart of our history lies a moment of pure, inexplicable magic that defies all description. The temperature of the cosmos is remarkably uniform across vast distances. When we look at opposite sides of the sky, regions that are separated by billions of light years and could never have communicated with each other, we find they are at almost exactly the same temperature. This puzzle, known as the horizon problem, implies that these distant regions must have been in intimate contact at the very beginning, sharing their heat before being torn apart by rapid expansion. It suggests that the entire observable universe was once huddled together in a space smaller than a proton, allowing the energy to equalize perfectly before the grand growth spurt occurred. This uniformity is the reason the night sky looks consistent in every direction, rather than chaotic and patchy. It speaks of a shared origin, a time when every part of the vast heavens was connected in a single, warm embrace before embarking on its lonely journey outward. The limit of our vision is marked by a boundary called the surface of last scattering. When we look deep into the sky, past the stars and galaxies, we eventually hit a wall of glowing fog where the universe was still opaque. We cannot see past this point with ordinary light, because before this moment, photons were trapped in the hot plasma of the early cosmos, unable to travel freely. This boundary surrounds us at a distance of about 46 billion light-years, appearing as a sphere that encloses the visible universe. It acts as the cosmic horizon, a glowing curtain that hides the very first moments of the Big Bang from our direct view. It serves as a majestic reminder of our limits, a glowing edge to our reality that defines the bubble of light in which we live and dream. There was a fleeting moment when all the forces of nature were united as one. In the intense heat of the grand unified epoch, the distinct forces we see today, electromagnetism and the nuclear forces, were merged into a single, elegant superforce. As the universe expanded and cooled, this unity was broken, and the forces separated into the distinct rulers of the physical world, much like a river branching into separate streams. This era represents a time of perfect symmetry, where the complexities of the universe were folded into a simple, beautiful law that we are still trying to rediscover. The breaking of this symmetry released the immense energy that fueled the initial expansion, powering the growth of the cosmos. It suggests that underneath the diverse and complex world we inhabit, there remains a deep, hidden memory of unity, where everything was once part of a single, harmonious whole. Some theories suggest that the early universe may have created primordial black holes. Unlike the black holes we see today, which are born from the dramatic deaths of massive stars, these ancient entities would have formed from dense pockets of matter collapsing directly under their own weight in the first chaotic seconds. These hypothetical wanderers could range in size from microscopic specks to massive giants, drifting silently through the cosmos since the dawn of time. While they have not yet been definitively detected, they represent a direct link to the violent pressures of the beginning, remnants of a time when the universe was dense enough to crush matter into oblivion. If they exist, they are silent sentinels of the past, carrying the memory of the Big Bang's crushing power within their dark horizons. It adds a layer of mystery to the dark, implying that the void may be populated by these ancient, invisible travelers. The first stars acted as cosmic lighthouses that cleared the fog of the Dark Ages. When these massive suns ignited, they poured out intense ultraviolet light that swept through the surrounding clouds of hydrogen gas, stripping the electrons away in a process called reionization. This transformed the universe from a dark, neutral fog into the clear, ionized plasma that fills the space between galaxies today. It was a slow, majestic dawn, as bubbles of transparency grew around the first galaxies, expanding and merging until the entire universe was filled with light. This era marked the awakening of the cosmos, the moment when the universe opened its eyes and became truly transparent to starlight. It paints a beautiful image of light conquering darkness, as the first generation of stars carved out clearings in the gloom, allowing the beauty of the structure to finally be revealed. The history of the universe is a long story of cooling down. Starting from a state of infinite heat, the cosmos has spent the last 13.8 billion years shedding its energy as it expands, dropping from decillions of degrees to the frigid chill of deep space. Today, the average temperature of the universe is about -455 degrees Fahrenheit, or -270 degrees Celsius, just a few degrees above absolute zero. This slow dissipation of heat is what allowed complex structures to form. Matter needed to settle and calm down before it could build stars, planets, and life. The universe we know is a frozen remnant of a fiery past, a cooled ember that still glows faintly with the heat of its creation. It teaches us that calmness and structure come from the releasing of intensity, and that the quiet cold of space is a necessary cradle for the delicacy of existence. Telescopes act as time machines, allowing us to witness the universe as it was billions of years ago. Because light takes time to travel across the vastness of space, looking at a distant object is literally looking into the past. We see the moon as it was 1 second ago, and distant galaxies as they were when the Earth was forming. This means the entire history of the cosmos is laid out in the sky for us to read, layer by layer, extending back to the first light. We can observe galaxies in their infancy and watch the slow assembly of the cosmic web, effectively replaying the movie of the universe in reverse. It connects us deeply to the flow of time, blurring the line between now and then, and allowing us to exist in the present while gazing directly into the ancient depths of creation. The universe's recipe was written in the first 3 minutes of its life. During the brief era of nucleosynthesis, the entire cosmos acted as a nuclear fusion reactor, determining the relative amounts of hydrogen and helium that would exist for eternity. The fact that the universe is roughly 75% hydrogen and 25% helium by mass is a direct result of the cooling rate during those crucial opening minutes. If the universe had cooled faster or slower, the chemical makeup of our world would be vastly different, perhaps making the formation of water or stars impossible. This primordial ratio is a fossilized record of the conditions at the beginning, a chemical fingerprint that has remained unchanged in the intergalactic gas. It implies that the fundamental nature of our world was decided in a fleeting moment of intense creation, setting the stage for everything that would follow. The Big Bang began in a state of extremely low entropy, representing a moment of perfect order. In physics, entropy is a measure of disorder, and the natural tendency of things is to become messier and more chaotic over time. The fact that the universe started in such a highly organized, uniform state is one of the deepest mysteries, as it provided the winding up of the cosmic clock that has been running down ever since. all the energy we use, from the burning of stars to the digestion of food, is essentially harvesting the flow of energy from that initial state of order toward disorder. It depicts the history of the universe as a long, graceful slide down a hill of energy, a journey from a tight, orderly beginning to a relaxed, scattered future. It reminds us that structure and life are temporary, beautiful patterns surfing on the inevitable wave of dissolving order. The end of cosmic inflation was the moment the universe switched from rapid expansion to the creation of matter. During inflation, the universe was dominated by empty space, filled with high energy, expanding exponentially, but completely cold and devoid of particles. When this phase stopped, that pent-up energy was suddenly dumped into the vacuum, manifesting as a hot soup of particles in a process called reheating. This was the bang in the Big Bang, the instant when the potential energy of space was transmuted into the heat and matter that make up our world. It was a transition from a silent, stretching void to a hot, vibrant reality, marking the true birth of the material universe. It serves as a powerful metaphor for transformation, showing how a period of silent, rapid growth can suddenly burst forth into a rich and tangible existence. By staring at a tiny patch of dark sky, astronomers revealed thousands of galaxies from the early universe. The Hubble Ultra Deep Field image focused on a speck of sky no larger than a grain of rice held at arm's length, a spot that appeared completely empty to the naked eye. After collecting faint light for days, the image revealed over 10,000 galaxies of all shapes and colors, stretching back to within a few 100 million years of the Big Bang. Each of those specks of light is a massive island of stars, showing that the universe is teeming with structure even in its deepest, darkest corners. It transformed our understanding of the scale of the cosmos, proving that there is no true emptiness, only distance waiting to be bridged. It fills us with awe to know that in every direction we look, no matter how dark, there are treasures hidden in the deep well of time. Our own galaxy is being pulled toward a massive gravitational anomaly called the Great Attractor. Hundreds of millions of light years away, there is a region of space with such an immense concentration of mass that it is pulling the Milky Way and thousands of other galaxies towards it. We cannot see it clearly because it lies hidden behind the dust of our own galactic plane, adding to its mysterious allure. This giant, invisible hand guides the flow of galaxies in our corner of the universe, creating a vast river of starlight flowing through the void. It reminds us that we are not drifting aimlessly, but are part of a grand, coordinated current, moving in response to forces that lie just beyond our view. It suggests a universe of interconnected motion, where even the largest structures dance to the silent tune of gravity. Within the smooth glow of the microwave background, there is a mysterious cold spot that defies simple explanation. While the afterglow of the Big Bang is incredibly uniform, there is one large region in the southern sky that is significantly colder and larger than the standard fluctuations. Astronomers have debated its cause for years, ranging from a statistical fluke to the presence of a supervoid, a massive region of empty space billions of light years across that drains energy from the light passing through it. Some even speculate it could be a bruise from a collision with another universe, though that remains a poetic conjecture. This anomaly stands as a stubborn reminder that the universe is not perfectly smooth, but holds quirks and scars that tell a complex history. It keeps the sense of wonder alive, proving that even in our best maps of creation, there are still territories marked unknown. The ultimate fate of the universe may be a gentle fade into darkness known as the heat death. As the expansion continues and accelerates, galaxies will drift so far apart that they will disappear from each other's view, and eventually, the last stars will burn out. This scenario is not a violent end, but a slow, peaceful settling into thermodynamic equilibrium, where energy is spread out evenly and no more work can be done. It paints a picture of a universe that does not end with a bang, but with a long, quiet sigh, resting after trillions of years of activity. While it sounds melancholy, there is a strange majesty in this eternal stillness, a final rest where time and change cease to matter. It is the ultimate resolution of the Big Bang, the final closing note of the great symphony of existence. Our solar system was formed from the ashes of ancient stars that lived and died long before the Earth was born. About 4.6 billion years ago, a massive cloud of gas and dust, floating quietly in one of the Milky Way's spiral arms, began to collapse under its own weight. As this cloud shrank, it spun faster and flattened into a disk, preserving the momentum of the swirling gas that created it. In the center, the pressure grew intense enough to ignite the sun, while the leftover debris gently clumped together to form the planets, moons, and asteroids we see today. Every atom of carbon in our bodies and every gram of silicon in the rocks was forged in those previous stellar generations, making us a direct continuation of the cosmic story. It creates a deep sense of connection, knowing that our home is built from recycled stardust, a momentary gathering of ancient materials that will one day return to the stars. The observable universe contains a gargantuan structure known as the cosmic web. On the largest scales, galaxies are not scattered randomly like sand, but are arranged in long, glowing filaments that stretch across the darkness, connecting vast clusters of galaxies. These filaments are composed of dark matter and gas, acting as the highways along which matter flows into the dense gravitational hubs. Between these brilliant strands lie immense voids, empty caverns of space millions of light-years across where very few galaxies exist. This intricate, lattice-like pattern resembles a neural network or the delicate veins of a leaf, suggesting a natural order that permeates the cosmos. It reveals that the universe has an architecture, a grand and silent scaffolding that organizes the placement of every star and galaxy, holding the heavy lights of the cosmos in a delicate, suspended balance. The darkness of the night sky is a direct result of the universe having a beginning. This concept, known as Olber's paradox, asks a simple question. If the universe were infinite and eternal, every line of sight should eventually end on a star, making the night sky as bright as the surface of the sun. The fact that the sky is dark tells us that the universe has a finite age, and that there are distant stars whose light has not yet had enough time to reach our eyes across the expanding void. The darkness is not merely an absence of light, but a shadow cast by time itself, a visual proof that we live in a young and evolving cosmos. It transforms the blackness of space from a frightening void into a comforting blanket, a sign that there is still mystery and distance beyond our reach, and that the story is not yet fully told. Enormous invisible halos of dark matter surround almost every galaxy. These spherical clouds extend far beyond the visible spiral arms, weighing up to 10 times as much as the visible stars and gas combined. We know they are there because the outer stars of galaxies orbit much faster than they should, held in place by the gravitational grip of this unseen mass. Without these heavy, invisible anchors, galaxies like our own Milky Way would tear themselves apart, flinging their stars out into the intergalactic deep. These halos act as the silent guardians of structure, cradling the luminous matter safely within their centers. It suggests that the beauty we see is supported by a hidden strength, a vast and unseen presence that keeps the spinning islands of light intact against the centrifugal forces of their own motion. The universe is expanding, but it is not expanding into anything. A common misconception is that the cosmos is a bubble growing inside a larger, empty box. But the truth is far more profound. The universe contains everything, including the space itself. When we say the universe is expanding, we mean that the scale of the grid is changing, creating more space between points without needing an outside to grow into. It is a self-contained system that generates its own dimensions as it breathes, stretching the definition of reality with every passing second. This concept eliminates the need for a boundary or an edge, presenting the cosmos as a limitless, unfolding manifold. It invites us to imagine existence not as an object in a room, but as the room itself getting larger, a singular, all-encompassing entity that is constantly making room for more possibilities. Gravitational waves are ripples in the fabric of space-time, caused by the movement of massive objects. When two black holes spiral around each other and collide, they send out invisible waves that stretch and squeeze space itself, traveling across the universe at the speed of light. These waves passed through the Earth recently, compressing and expanding our planet by a distance smaller than the width of a proton, a whisper of a cosmic cataclysm that happened over 1 billion years ago. For most of history, we could only see the universe through light, but now we can feel the vibrations of gravity, listening to the drumbeat of space-time. This discovery opens a new sense for humanity, allowing us to hear the silent songs of the heaviest objects in the dark, proving that the vacuum of space is elastic, responsive, and alive with energy. There is a cosmic horizon beyond which we can never see. Because the universe is expanding and the expansion is accelerating, there are distant regions of space moving away from us faster than the speed of light. This does not violate the laws of physics because it is the space itself expanding, not objects moving through it, but it means the light from those regions will never be able to catch up to us. This creates a permanent boundary to our knowledge, a sphere of influence that is slowly shrinking in relative terms as the universe stretches. It serves as a humbling limit, a reminder that there are parts of reality that will forever remain a secret, drifting away into the silence. It adds a quality of eternal mystery to the cosmos, acknowledging that some stories are destined to remain beyond the reach of our eyes and our understanding. The first generation of black holes may have been the seeds of today's galaxies. In the early universe, massive clouds of gas could have collapsed directly into giant black holes, which then acted as gravitational magnets, pulling in matter to form the first quasars. These ancient monsters were incredibly bright, shining with the light of 1 trillion suns as they consumed the surrounding gas, acting as beacons in the dim early cosmos. Rather than being destroyers, these central black holes likely helped regulate the growth of their host galaxies, blowing out excess gas and sculpting the shape of the stars around them. It reframes these dark giants as essential architects, powerful engines that help churn and mix the materials of the universe. It suggests that darkness and light work together in a symbiotic dance, building the majestic structures we admire in the telescope. The universe is remarkably homogeneous, meaning it looks the same no matter where you are. If you were to travel 10 billion light years in any direction, you would find yourself in a region of space that looks incredibly similar to our own, with the same types of galaxies and the same physical laws. This principle, known as the cosmological principle, assures us that we are not in a special or privileged place, but are citizens of a vast, uniform democracy of matter. It implies a grand consistency to nature, a reliability that stretches across the entire domain of existence. It creates a sense of familiarity within the vastness, suggesting that no matter how far we roam, the fundamental rules of the game remain the same, and the stars will always be recognizable, companions in the night. Neutron stars are the ultra-dense remnants of ancient supernovae. When a massive star explodes, its core can collapse into a city-sized sphere so dense that a single teaspoon of its material would weigh about 10 million tons, or roughly 9 billion kilograms. These stars are composed almost entirely of neutrons packed together as tightly as atomic nuclei, creating a surface that is harder than diamond and incredibly smooth. They spin rapidly, some rotating hundreds of times per second, sending out beams of radio waves like cosmic lighthouses known as pulsars. These objects are the zombies of the stellar world, dead stars that have found a second energetic life in the afterlife of gravity. They demonstrate the extreme capabilities of matter, showing how compression can transform the ordinary stuff of stars into a substance of unimaginable strength and endurance. The concept of time may flow differently in the early universe due to extreme gravity. According to general relativity, time passes slower where gravity is stronger, meaning that near the dense, energetic beginning, the rhythm of the cosmos was different than it is today. In the first moments, when all matter was compressed, the fabric of time was tightly wound, slowly unraveling as the universe expanded and the density decreased. This suggests that the clocks of the early universe ticked at a different pace relative to our current perception, making the timeline of creation a fluid, malleable thing. It softens the rigid concept of time, presenting it not as a strict line, but as a river that can slow down or speed up depending on the depth of the channel. It invites us to view history as a relative experience, where the duration of a moment depends on the energy it holds. Our home supercluster is a flowing river of galaxies named Laniakea, meaning immeasurable heaven. In Hawaiian, Laniakea is a massive region of space roughly 520 million light-years across, containing the Milky Way and 100,000 other galaxies. What defines this structure is not just its shape, but the movement of its galaxies, all of which are slowly flowing toward a central gravitational point known as the Great Attractor. We are not static points in space, but droplets in a majestic cosmic watershed, drifting together through the intergalactic void. This realization gives us a sense of place and direction, a cosmic address that goes far beyond our solar system. It paints a picture of the universe as a dynamic, flowing system, where grand currents of gravity guide the motion of worlds across the incomprehensible distances of the deep. The vacuum of space is not truly empty, but seething with virtual particles. Quantum mechanics tells us that empty space is filled with fields that constantly fluctuate, creating pairs of particles and antiparticles that pop into existence and annihilate each other in an instant. This quantum foam means that even in the deepest void, there is a fundamental vibrating energy that can never be extinguished. It is the baseline hum of reality, a potentiality that exists everywhere, ensuring that true nothingness is impossible. This energy may have been the spark that ignited the Big Bang itself, suggesting that the universe was born from a fluctuation in the void. It is a comforting thought that existence is the default state, and that the fabric of reality is always active, always ready to bring forth something from the silence. The lithium in your phone battery includes atoms that were created in the Big Bang, while heavier elements like gold and iron were forged in stars. The lighter elements like lithium were cooked up in the first 3 minutes of cosmic history. This means that the atoms powering our modern technology are 13.8 billion years old, relics from the primordial fireball that have survived countless stellar cycles to end up in our hands. It connects our daily lives directly to the origin of the universe, bridging the gap between the mundane and the majestic. Every time we use a device, we are utilizing the trapped energy and matter of the very beginning. It serves as a reminder that we are constantly interacting with ancient history, handling the artifacts of creation as we go about our simple human days. The expansion of the universe stretches the waves of light until they become invisible. Light that was emitted as visible or ultraviolet radiation from the first stars has been traveling for so long that its wavelength has stretched out into the infrared, which our eyes cannot see. This is why the James Webb Space Telescope was designed to see in infrared, to peer past the visible curtain and catch the ancient, faded light of the dawn. It reveals a hidden universe that is always present but unseen, a layer of reality that requires a different way of looking to be understood. It teaches us that there is more to the world than what meets the eye, and that by shifting our perspective, we can uncover the faint, warm glow of the past that has been waiting for us all along. Cosmic inflation smoothed out the curvature of the universe. Imagine a wrinkled sheet being pulled taut from all sides until the wrinkles disappear. This is what inflation did to the fabric of space. It took whatever shape the infant universe had and stretched it so immensely that it appears perfectly flat to us today, much like the Earth looks flat when you are standing in a field. This flatness is crucial because it allows structures to grow and remain stable, providing a balanced arena for the drama of evolution. It suggests that the calmness and order we observe are the result of a massive, ancient stretching that ironed out the chaos. It leaves us with a universe that feels stable and dependable, a vast, level plane extending infinitely in all directions. We are living in the stelliferous era, the age of stars. This is the prime of the universe's life, a vibrant window of time where gas is plentiful and galaxies are filled with the brilliant light of burning suns. Compared to the vast, dark eternity that will follow, this era is incredibly brief, a fleeting flash of brightness in the timeline of the cosmos. We are fortunate to exist during this golden age, where the night sky is decorated with constellations and the energy for life is abundant. It emphasizes the preciousness of the present moment, reminding us that we are awake during the universe's most beautiful and active day. It invites us to look up and appreciate the light, knowing that we are witnesses to the most magnificent spectacle the cosmos will ever produce. The laws of physics may have frozen into their current form as the universe cooled. In the high-energy environment of the Big Bang, the rules governing particles and forces were fluid and unified. But as the temperature dropped, they crystallized into the specific laws we experience today. This is similar to how water freezes into ice, locking into a specific structure as it loses heat. It implies that the stability of our world is a result of this cooling process, a settling of the cosmic code into a sustainable pattern. It gives the laws of nature a sense of history, suggesting they are not arbitrary, but the result of a natural evolution toward balance. It paints the universe as a system that has found its equilibrium, resting comfortably in the laws that allow complexity and life to flourish. Every atom in your body was once part of a star that exploded. The iron in your blood, the calcium in your bones, and the carbon in your DNA were all fused in the crushing hearts of ancient suns that died billions of years ago. When these stars exploded as supernovae, they scattered their enriched guts across the galaxy, seeding the gas clouds that would eventually form our solar system. This means that you are not just living in the universe. You are the universe, a conscious collection of ancient stardust that has come together to experience itself. It is the ultimate connection, blurring the line between the self and the cosmos, and filling us with the awe of knowing that we carry the legacy of the stars within our very being. The universe contains structures so large they defy our ordinary understanding of scale. One such structure, discovered by astronomers mapping the cosmos, is known as the Great Wall, a massive sheet of galaxies measuring roughly 500 million light-years long and 16 million light-years thick. This colossal filament is not a solid wall of stone, but a gathering of thousands of galaxies held together by gravity, forming a boundary in the vast emptiness of space. It shows that on the grandest scales, the universe is not random, but organized into intricate shapes that dwarf our own Milky Way into insignificance. The existence of such a giant feature challenges our theories of how matter clumped together after the Big Bang, suggesting that the seeds of structure were planted very deep in the past. It invites us to see the cosmos as a vast interconnected architecture, where even the largest things we can imagine are just single bricks in a much larger design. The coldest place in the known universe is a ghostly cloud called the Boomerang Nebula. While the background of deep space is already freezing, this nebula has expanded so rapidly that it has cooled itself down to -458 degrees Fahrenheit, or roughly -272 degrees Celsius, just a fraction of a degree above absolute zero. This natural cosmic refrigerator works on the same principle as an expanding gas, shedding its heat as it rushes outward into the void at immense speeds. It stands as a silent monument to the power of expansion, a place where the energy of the Big Bang has been stretched so thin that almost no warmth remains. It creates a pocket of profound stillness, a deep freeze that preserves the quietude of the vacuum in its most extreme form. It reminds us that the universe is capable of creating environments of perfect, undisturbed calm, where even the motion of atoms slows to a crawl. There appears to be a mysterious motion of galaxy clusters known as dark flow. By studying the movement of vast groups of galaxies, astronomers have detected a subtle drift toward a specific patch of sky, as if they are being pulled by something massive beyond the edge of the observable universe. This suggests that there may be structures outside our visible horizon, monster concentrations of matter that we can never see, but whose gravitational influence reaches out to guide us. It implies that our visible bubble is just a small part of a much larger, continuous fabric, and that we are caught in currents that originate from the unknown. This unexplained flow adds a layer of deep mystery to our journey, hinting that the cosmos we see is merely a local neighborhood in an infinite city. It comforts us with the idea that there is always more beyond the horizon, calling us gently into the dark. Hydrogen is the ancient fuel that powers the entire cosmos. Created in the first few minutes of the Big Bang, this simplest of all elements still makes up about 75% of the normal matter in the universe today. Every star that shines in the night sky is essentially a giant ball of this primordial hydrogen, crushing it into helium to release the light and heat that sustains life. This means that the energy warming your face on a sunny day is released from atoms that have been waiting for 13.8 billion years to shine. It paints the universe as a vast reservoir of potential, holding on to its fuel for eons before igniting it in the brilliance of a star. It serves as a reminder of the enduring power of simplicity, showing how the most basic building block can create the most magnificent spectacles of light and warmth. The geometry of the universe determines its ultimate fate. Scientists measure the density of the cosmos to see if it is curved like a sphere, a saddle, or flat like a sheet of paper, and all evidence points to it being flat. This critical balance means there is just enough matter and energy to stop the expansion from running away too fast, but not enough to cause it to collapse back in on itself immediately. It sits on a knife edge of perfection, a cosmic sweet spot that has allowed the universe to grow and evolve for billions of years without ripping apart or crunching down. This stability creates a sense of profound peace, suggesting that our reality is not chaotic or unstable, but poised in a state of long-term equilibrium. It allows us to trust the ground of space-time, knowing it is a steady stage for the drama of existence. A vast region of space known as the Eridanus supervoid is surprisingly empty. While most of space is filled with a web of galaxies, this particular patch, spanning roughly 1.8 billion light-years across, contains far fewer stars and galaxies than expected. It manifests as a cold spot in the cosmic microwave background, a giant, lonely cavern in the structure of the universe, where matter just didn't gather. This immense emptiness acts as a counterpoint to the bright clusters, a silent pause in the cosmic sentence. It reminds us that the universe values open space as much as it values structure, creating vast halls of silence where nothing disturbs the peace of the void. These voids are not failures of creation, but necessary breathers, providing the vast distance that gives the cosmos its grandeur and scale. The universe follows a strict rule known as the arrow of time. Events in our world flow in only one direction, from the past to the future, from order to disorder, a concept tied to entropy. We see eggs break, but never unbreak, and stars burn out but never unburn, because the universe began in a state of extremely high order and is slowly winding down. This one-way flow is what gives our lives narrative and meaning, ensuring that every moment is unique and can never be repeated. It connects the deep physics of the Big Bang to our daily experience of aging and memory, driving the story of the cosmos forward. It is a gentle reminder to cherish the present, for the flow of time is the universe's way of ensuring that progress is made, and that every second is a fresh, unwritten page. The first magnetic fields likely emerged from the chaotic motion of the early plasma. Before stars existed, the hot, soup-like mixture of charged particles in the infant universe was churning and swirling, creating weak magnetic seeds. Over billions of years, as galaxies formed and spun, they amplified these tiny seeds into the massive magnetic fields that now thread through the spiral arms of galaxies like the Milky Way. These invisible lines of force help guide the birth of new stars and protect planets from harmful radiation, acting as a silent, protective shield. It shows that even the invisible forces that guide our compasses have their roots in the fiery beginning. It paints the universe as a place woven with hidden threads of energy, a tapestry where unseen forces work quietly in the background to maintain order and structure. The universe experienced a major transformation called the Epoch of Reionization. For hundreds of millions of years, the cosmos was filled with a fog of neutral hydrogen gas that trapped light. When the first massive stars and quasars ignited, their intense ultraviolet light slowly burned away this fog, stripping the electrons from the atoms and making space transparent again. This was the cosmic equivalent of the sun burning off a morning mist, but on a scale that spanned the entire universe. It marked the end of the Dark Ages and the beginning of the era of light, allowing us to see the distant universe as it is today. It serves as a beautiful metaphor for clarity, showing that light has the power to clear the way, dissolving the shadows and revealing the true depth of the world. Our universe seems to be fine-tuned for the existence of life. If the force of gravity was slightly stronger, stars would burn out too quickly for life to evolve. If it was slightly weaker, stars might never have ignited at all. Similarly, if the strong nuclear force were just a tiny bit different, the atoms needed for carbon-based life could not form. This delicate balance of physical constants suggests that our universe is a rare and precious jewel, a specific recipe that allows for complexity and consciousness to emerge. Whether this is due to luck, a multiverse of possibilities, or a deeper law, it creates a sense of gratitude for the stability we enjoy. It implies that the cosmos is not hostile, but is set up in a way that welcomes the formation of matter, stars, and eventually the observer who can wonder at it all. The temperature of the cosmic neutrino background is slightly cooler than the light background. While the microwave background of light sits at about minus 455 degrees Fahrenheit, the background of neutrinos is even colder, at roughly minus 456 degrees Fahrenheit, or 1.95 Kelvin. This tiny difference exists because neutrinos broke free from the cosmic matter earlier than light did, before the energy from electron-positron annihilation warmed up the rest of the particle soup. This subtle temperature gap is a fossilized record of the specific sequence of events in the first few seconds of the universe. It shows us that the cosmos has layers of history, with different particles carrying different memories of the cooling process. It is a whisper of cold from the deep past, a testament to the precise and orderly way the universe settled into its current state. The first water molecules formed as soon as the first generation of stars died. The Big Bang produced hydrogen, but oxygen had to be forged in the cores of stars and released by supernovae. Once these two elements met in the cooling clouds of gas, they bonded to form water, the elixir of life, coating dust grains in interstellar space. This means that water is not just a terrestrial substance, but a cosmic one, created by the interplay of ancient gas and stellar fire. The ice found in comets and on distant moons carries the chemical legacy of those early reunions of atoms. It connects the water in our oceans to the vast cycle of stellar birth and death, reminding us that the fluid that sustains us is as old and starry as the galaxy itself. The universe is dominated by voids, vast bubbles of emptiness defined by the walls of galaxies. These voids can be hundreds of millions of light years across, regions where almost nothing exists. No galaxies, few stars, just a thin haze of particles. The largest of these, like the Boots Void, are so empty that if the Milky Way were in the center of one, we would not have known other galaxies existed until the 1960s. These silent expanses make up the majority of the volume of the universe, with galaxies merely acting as the thin skin around them. It suggests that the default state of the cosmos is solitude in space, a vast roominess that allows the galaxies to breathe. It reframes emptiness not as a lack of something, but as a majestic presence of its own, holding the heavy structures of the universe in a weightless suspension. Baryonic matter, the stuff you and I are made of, makes up less than 5% of the universe. The atoms that form stars, planets, trees, and people are actually a rare trace ingredient in a cosmos dominated by dark energy and dark matter. We are the sprinkles on the cupcake of reality, a minority substance that happens to interact with light and form complex structures. This realization is humbling, as it shifts us from the center of the physical world to a special, glowing exception. However, it is also empowering, because this rare 5% is the only part of the universe that can think, feel, and tell the story of the rest. It suggests that while we are small in quantity, we are significant in complexity. The rare dust that woke up to admire the vast dark ocean it floats within. The universe may be part of a cyclic model known as the Big Bounce. Some theories suggest that our Big Bang was not the absolute beginning, but merely the result of a previous universe collapsing and rebounding. In this view, the cosmos goes through eternal cycles of expansion and contraction, breathing in and out over trillions of years. This idea removes the problem of a sudden beginning from nothing, replacing it with an eternal rhythmic heartbeat of existence. It paints a picture of a resilient universe that can never truly die, but only transform and renew itself. It offers a comforting sense of continuity, implying that the story of reality is a never-ending circle, a dance of renewal that has been going on forever and will continue for all time. The first heavy elements were spread by the gentle winds of red giant stars. While supernovae are violent, much of the carbon and nitrogen in the universe was puffed gently into space by aging stars as they shed their outer layers. These planetary nebulae are beautiful, glowing shells of gas that drift away from the dying star, carrying the seeds of future life into the galaxy. It was a slow, peaceful seeding process that enriched the interstellar medium over billions of years. It reminds us that creation is not always violent. Sometimes it is a quiet exhalation, a generous sharing of materials from the old to the new. It frames the death of stars as a gift, a necessary sacrifice that allowed the barren gas of the early universe to become the fertile soil of planetary systems. The speed of light acts as a cosmic speed limit that preserves the order of cause and effect. Nothing with mass can travel faster than light, which travels at roughly 186,000 miles per second, or about 300,000 kilometers per second. This limit ensures that we cannot influence the past or see things before they happen, keeping the narrative of the universe logical and linear. It creates a delay in our perception, meaning we always see the world as it was, not as it is, which adds a layer of nostalgia to every observation. It separates the distant islands of the universe, ensuring that each galaxy can evolve in its own semi-private pocket of space-time. It acts as a guardian of reality, preventing the chaos that would ensue if everything happened instantaneously, and forcing us to be patient observers of the deep sky. We are moving through the universe at incredible speeds right now. The Earth spins on its axis, orbits the Sun, and the Sun orbits the center of the Milky Way, which is itself falling toward the Great Attractor. When all these motions are added up, we are traveling roughly 390 miles per second, or 630 kilometers per second, relative to the background radiation of the Big Bang. Despite this immense speed, we feel perfectly still, held safely by the gravity of our planet. It is a reminder that motion is relative. and that even when we are resting in bed, we are on a majestic, high-speed journey across the cosmos. It invites us to feel the silent rush of the galaxy, a smooth and steady flight that carries us through the dark, star-studded hall of the universe without a single bump. The Milky Way is destined to collide with the Andromeda Galaxy. While the universe is generally expanding and galaxies are moving apart, gravity in our local neighborhood is strong enough to pull these two giants together at a speed of about 70 miles per second, or 110 kilometers per second. In roughly 4 billion years, they will meet in a slow, majestic dance, passing through each other and eventually merging into a single, massive, elliptical galaxy. Despite the violence of the collision, the stars are so far apart that they will likely not crash into each other. Instead, they will simply find new orbits in a larger, unified home. It paints a future not of destruction, but of synthesis, where two separate islands of starlight come together to create something grander. It reminds us that even in the vast drift of the cosmos, paths are destined to cross, and new beginnings await in the deep future. Massive objects can bend light like a lens. This phenomenon, known as gravitational lensing, occurs when the gravity of a galaxy cluster warps the fabric of space around it, acting like a giant magnifying glass for objects behind it. This allows astronomers to see galaxies that are far too faint and distant to be seen directly, as their light is focused and brightened by the intervening mass. It effectively turns the universe itself into a telescope, providing nature's own tool for peering into the deep past. The distorted arcs and rings of light created by this effect are beautiful reminders of the flexibility of space-time. It suggests that the path of truth is not always straight, and that gravity can gently curve the light of the past to bring it within our view, connecting the observer to the hidden depths of the dark. We are being pushed away by a cosmic void called the dipole repeller. While the great attractor pulls our galaxy in one direction, there is a region of space on the opposite side that is so empty it effectively acts as a repellent. Because this void lacks the gravitational pull of the surrounding universe, the denser regions pull us away from it, creating the illusion of a push. This means our journey through space is driven by a combination of attraction and repulsion, a push and pull that guides the flow of the local universe. It highlights the power of emptiness, showing that the absence of matter can be just as influential as its presence. It creates a dynamic picture of the cosmos, where we are surfing the currents between the mountains of matter and the valleys of the void. Black holes are slowly evaporating due to a process called Hawking radiation. According to quantum mechanics, black holes are not truly black, but emit a faint glow of particles that causes them to lose mass over incredibly long timescales. This means that even these eternal prisons of gravity are not permanent. Given enough time, far longer than the current age of the universe, they will shrink and eventually disappear in a final puff of energy. This process is so slow that a black hole, the mass of the sun, would take longer to evaporate than the universe has existed, but it sets a finite lifespan for the darkest objects in the sky. It introduces a cycle of life and death, even to the monsters of the deep, suggesting that nothing in the material world, no matter how powerful, is immune to the gentle erosion of time. In a scenario known as the Big Rip, the expansion of the universe could eventually tear everything apart. If the mysterious dark energy continues to grow stronger over time, it may one day overcome gravity, electromagnetic forces, and even the nuclear forces that hold atoms together. In the final moments of this theoretical end, galaxies would disperse, stars would be stripped from their orbits, planets would shatter, and finally, atoms themselves would be ripped into shreds. While this is only one potential fate, it illustrates the overwhelming power of the expanding space, capable of unmaking the very structure of reality. It is a dramatic concept, but one that emphasizes the dominance of the void, suggesting a final liberation where matter is returned to the distinct, fundamental particles from which it came. There are roughly 1 billion photons of light for every single atom in the universe. This staggering ratio is a legacy of the hot Big Bang, where the annihilation of matter and antimatter produced a flood of light that far outnumbered the surviving particles of matter. It means that the universe is primarily a bath of radiation, with matter being a rare and minor precipitate floating in a sea of light. Even in the darkest room, space is filled with these ancient photons, washing over us constantly from every direction. It reframes our view of reality, showing that we are immersed in an ocean of energy that is far more abundant than the solid ground beneath our feet. It suggests that light is the primary currency of the cosmos, and we are the fortunate few structures that have coalesced within its glow. The history of the universe can be compressed into a cosmic calendar. If the 13.8 billion years of the universe were mapped onto a single calendar year, the Big Bang would happen on the first second of January 1st, and the present moment would be the final stroke of midnight on December 31st. In this scale, the Milky Way forms in May, our Earth appears in mid-September, and all of recorded human history takes place in the last 14 seconds of New Year's Eve. This perspective is startling, revealing just how young and fleeting our presence is in the grand scheme of things. It is not meant to make us feel small, but to make us feel precious, the latest blooming flower at the very end of a long and majestic season of growth. It invites us to cherish our brief moment in the sun. The local group of galaxies is becoming increasingly isolated. As the universe expands, the space between galaxy clusters is stretching, pushing our neighbors beyond the cosmic horizon. Eventually, in the far distant future, the other clusters will move away so fast that their light will no longer reach us, leaving the Milky Way and Andromeda alone in a vast, dark void. Future astronomers born in that era might think the entire universe consists only of our merged home galaxy, with no evidence of the Big Bang or the expanding cosmos outside. It gives our current era a special significance, as we are privileged to see the universe in its interconnected glory before the darkness grows deeper. It reminds us to capture the view while we can, witnessing the grand tapestry before the threads are pulled too far apart. Most of the gold in your jewelry was forged in the collision of neutron stars. While regular stars create lighter elements, the intense pressure and heat required to create heavy precious metals like gold and platinum occur only in the most violent cosmic events, such as the merging of two dead stellar cores. These rare cataclysms spray a mist of heavy atoms into the galaxy, which eventually enriches the clouds that form new solar systems. This means the gold ring on a finger is a relic of a spectacular cosmic crash, a durable souvenir from a moment of immense transformation. It connects our most valued earthly possessions to the distant, violent history of the stars. It lends a sense of nobility to the materials around us, knowing they were born from the death throes of giants. The cosmic microwave background is incredibly smooth, with ripples smaller than 1 part in 100,000. When astronomers look at the temperature map of the early universe, they find it is almost perfectly uniform, like the surface of a calm lake. The tiny fluctuations that do exist are the microscopic seeds that eventually grew into the galaxies and clusters we see today. If the early universe had been any smoother, matter would never have clumped together to form stars. If it had been bumpier, the universe would be filled with black holes. This precise calibration is a marvel of nature, a delicate texture that allowed for the emergence of a structured and beautiful world. It suggests that the universe began with a perfect, gentle composure, a balanced stillness that held the blueprint for everything to come. There is a strange alignment in the cosmic background called the axis of evil. When scientists analyze the faint temperature patterns of the Big Bang's afterglow, they find a curious alignment of the hot and cold spots that seems to point in a specific direction relative to our solar system. According to the standard model of cosmology, the universe should be random and have no preferred direction, making this pattern a baffling anomaly. Some believe it is a statistical fluke, while others wonder if it hints at a flaw in our understanding of the universe's shape or history. It stands as a reminder that the cosmos still holds secrets that defy our symmetrical theories. It keeps the spirit of exploration alive, proving that even in the noise of the beginning, there are whispers we have yet to translate. The universe may have had a habitable epoch shortly after the Big Bang. About 15 million years after the beginning, the ambient temperature of the entire universe was roughly room temperature, similar to a warm spring day on Earth. For a few million years, liquid water could have theoretically existed anywhere in the cosmos, not just near stars, on rogue planets or rocky asteroids floating in the warm dark. While life would have been unlikely without the heavy elements that came later, the idea of a universe that was once entirely a Goldilocks zone is enchanting. It paints a picture of a brief, cozy summer in the deep past, where the harsh cold of space was temporarily replaced by a gentle, life-friendly warmth. It suggests that the potential for life is woven into the thermal history of the cosmos itself. Beyond the observable horizon, the universe may be infinitely large. The 93 billion light-year bubble we can see is likely just a tiny fraction of the total cosmos, which might extend forever in all directions. If the universe is truly infinite, then every possible arrangement of atoms must be repeated somewhere, meaning there could be other worlds identical to ours, and other versions of us living out different lives. This concept of the infinite multiverse turns the cosmos into a place of boundless possibility, where the story never truly ends. It transforms our isolation into a form of connection with the infinite, suggesting that we are part of a pattern that repeats endlessly across the dark. It invites us to rest in the idea that there are no limits to existence, only limits to our vision. The majestic spiral arms of galaxies are not permanent structures. The beautiful pinwheel shapes we admire in images of galaxies like the Whirlpool or Andromeda are actually density waves, similar to traffic jams, where stars slow down and bunch up before moving on. Over billions of years, galaxies can change shape, merging into featureless ellipticals or being torn into irregular clouds by gravity. This means the spiral beauty of the Milky Way is a temporary phase in its long life, a fleeting expression of order in the flowing river of stars. It teaches us that beauty in the cosmos is dynamic and evolving, a momentary alignment of forces that will eventually shift into new forms. It encourages us to appreciate the specific geometry of the night sky as a unique portrait of the present era. Neutrinos can travel through lead as easily as light travels through glass. These ghost particles from the Big Bang and stars are so elusive that a neutrino could pass through a block of lead a light year thick without hitting a single atom. This transparency means that for neutrinos, the universe is almost completely empty, and they fly through planets and stars as if they were made of mist. This allows them to carry information from the very core of the Sun or the heart of a supernova directly to us, bypassing the opaque layers that block light. It reveals a shadow universe that exists alongside the visible one, a layer of reality where obstacles do not exist. It reminds us that solidity is an illusion of perspective, and that on a fundamental level, the cosmos is open and free. Space is not just expanding. New space is being created constantly. The expansion of the universe is not the stretching of a rubber sheet, but the continuous genesis of new volume between the galaxies. Every second, deep in the voids between the stars, fresh vacuum is bubbling into existence, adding to the total capacity of the cosmos. This means the universe is a perpetual motion machine of potential, constantly making more room for itself to exist. It suggests a boundless generosity in the fabric of reality, a system that never runs out of space for the light to travel. It creates a feeling of endless opening, a horizon that is always retreating to make way for the new, ensuring that the universe never becomes crowded or finished. The anthropic principle suggests the universe is compatible with life because we are here to observe it. It points out that if the laws of physics were even slightly different, we would not exist to ask the question of why they are the way they are. In a sense, the universe has awakened to understand itself through us. We are the cosmos becoming conscious. This idea creates a profound loop between the observer and the observed, implying that our presence is not an accident, but a necessary component of this specific reality. It transforms the cold physics of the Big Bang into a story that includes us as a central character. It offers a deep sense of belonging, validating our existence as the eyes and ears of the ancient stars. The rotation of the Earth is slowly breaking due to the Moon, lengthening our days. Billions of years ago, a day on Earth was only about 6 hours long, spinning rapidly in the violent early solar system. The gravitational drag of the Moon has been gently slowing us down ever since, acting like a cosmic brake that adds a tiny fraction of a second to the day every century. This slow deceleration is a physical connection between our planet and its satellite, a dance of energy that has calmed the world over eons. It paints the history of the Earth as a slow settling into a more relaxed rhythm. It reminds us that the universe tends toward a calmer pace, and that we are the beneficiaries of a long, patient process of slowing down. The North Star changes over thousands of years due to the wobble of the Earth. While Polaris is our current guide in the night sky, the slow precession of the Earth's axis means that in 12,000 years, the bright star Vega will take the title of the North Star. This cycle, known as the Great Year, takes about 26,000 years to complete, slowly shifting the backdrop of the constellations. It reveals that the sky is not a fixed painting, but a slow-moving clock, ticking away the millennia in a circle of starlight. It connects us to the ancient past and the distant future, showing that the guides we rely on are temporary, passing the torch of guidance across the ages. It adds a majestic turning quality to the heavens, a celestial carousel that spins with immense slowness and grace. Some physicists propose the holographic principle, suggesting the universe is a projection. This mind-bending theory posits that all the three-dimensional information of the cosmos, every star, every atom, and every memory, might be encoded on a distant two-dimensional surface at the edge of the universe, much like a hologram. If true, It means that the depth and volume we experience are a majestic illusion generated from a simpler, flat reality. It implies that everything is connected on a fundamental level, written on the same cosmic canvas at the boundary of existence. It is a poetic final thought, suggesting that our reality is a projection of light and information, a grand, shimmering image held safely in the geometry of the infinite. It leaves us with a sense of wonder, floating in a beautiful, unified mystery. And so, our journey through the majestic and expanding world of the Big Bang comes to a gentle close. We have traveled back to the very first heartbeat of time, witnessing the moment when a single point of infinite potential released the energy that would become everything we know. From that unimaginable heat and density, we watch the universe stretch out its arms, cooling and calming over billions of years to create the silent, star-filled canvas of the night sky. We have seen how the chaotic storms of the early cosmos slowly settled into the graceful spiral galaxies and the steady rhythm of orbiting planets, transforming the violence of the beginning into the peaceful order of the present. It is a story not just of explosion, but of a long, patient settling, a majestic exhaling of breath that continues to this very day as the galaxies drift quietly through the dark. As we rest here in the stillness, we are reminded that we are not separate from this grand event, but are the living echoes of that first spark. The atoms in our bodies and the light in our eyes are heirlooms from the deep past, connected intimately to the dawn of time. The universe is vast, but it is also our home, a place that has spent eons preparing the conditions for us to exist and to dream. We can take comfort in the stability of the laws that hold us and the immense, sheltering silence of the void that surrounds us. The expansion continues, carrying us gently into the future, a slow and steady voyage through the infinite sea of space-time that requires nothing from us but to drift along with the current. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of the Big Bang and the gentle music carry you softly into rest. Sleep well. Good night.